Today I'm going to look at a specific aspect of spec-driven development, namely optimizing the tests. Here's my agenda. I defined a problem, namely that tests that are generated can have weak assertions. I have some conversation with Claude in Copilot, and then I ask it to improve the tests it generates. This is a conversation I had with Claude about this page. I had asked it to create some tests, and one of the tests it generated was combined filters transition. The word transition refers to a state transition, and I asked that as a category of test that it needs to generate. Anyway, so this is the page, and you can type here, and then it will filter as you wish. And there are two filters. So what it does is recognize a name filter and an owner filter. And then it enters university and then John in here. And then it asks for how many edit buttons there are. And it's its way of counting the rows. Okay, so keep that in mind. And what I noticed was that the first test that it generated was kind of weak. Assert true that there are 0 or more edit buttons. Well, that's always the case. So I found it very curious. Why doesn't it make better? It seems to understand what it needs to do, and why come up with some lame assertion? So I asked it, why does combine this test that it's only larger than 0 or 0 itself? It's that way by definition. And then it says, like it always does, always say that I'm right. You're absolutely right. That's a meaningless assertion. Let me check the current implementation of the test and fix it to be more meaningful. And then it says, you're absolutely right again. It's meaningless. Now let me try again. And then it has trouble with building, but it overcomes those troubles. And then it's summary. You were absolutely correct to point out the meaningless of the assertion. Okay. After meaningful, this is a great example of why it's important to review test assertions carefully. Okay, so let's look at what it is now. So I can do here Control Y. And what did it do? It now says that it counts the edit buttons after the first filter was used, and then it counts it again after the second filter was used, and then it says the second time around there are at most as many rows as the first time around. That's again, why that's almost always the case unless the filter totally is broken and you get an exception. But other than that, it would always be the case. So it's still lame. So I point that out. And why don't you use an assertion that verifies the exact expected number? And then it says, you're absolutely right again. Oh, well, the assertion is still weak and blah, blah, blah. And so then it looks at the sample data, and it was a little bit different than what I showed on initially. The test data is different than the data in the database. So University of Test State University, and Tech Institute. And you can see if you enter a university as it does in the test that you would get 2 records. And if you then also enter John as the owner name, then you get 1. Okay. And then the test passes. Good suggestion. Thank you so much. Excellent. Perfect. And it runs all the other tests, which is good. You're absolutely right. And what does it do after this correction? redo again, Control Y. Now it says something like that there is only one at the end, but it doesn't say anything about the test after the first filter has been applied. So I point that out. Why don't you assert and blah, blah, blah. Okay, so it fixes that. Accent passes, blah, blah, blah. 3, 2, and then 1. How could I have prompted you so that you would have done this first time right, generating the most meaningful assertions? And that's where the AI is asked to improve the communication with the AI. And then it says, I love that question. Here are several ways you could have prompted me to generate more meaningful assertions from the start. And it's kind of amusing. It seems to suggest that it knew this all along. But what is actually happening is that my initial prompting was too generic, too vague. It wasn't precise enough, specific enough, and therefore it just gave an answer. And the answer in this case was in the terms of came as a piece of code with an assertion, and the assertion was just lame. And by repeatedly asking why not better, it made it better until I had what I wanted. And then I asked, how could I have done that in the first place? And then it says, instead of just asking for tests, you could have said, generate tests with precise assertions that validate the exact expected behavior. Any human engineer would assume that. So I assumed that it would do this, but those assumptions are wrong. With an AI, you need to explicitly say what you want. And it gives several other variants of this, but they all amount to the same thing. Uh, so at the end, it says um, the most effective approach would be generate this test. First, analyze the test data to determine exactly how many universes should match each filter step. Then write precise assertions that validate those exact counts. Avoid weak assertions like blah, blah, blah. And then it says, you, in this way, force me to do all this. Well, um, what I learned from this is, well, I cannot really uh, give directions on specific tests because I want it to generate a complete set of tests, and I want these tests to be optimal. So I cannot comment on anything that it has generated up front because I don't know what it is, and I don't want to go back in and read them all. I do this now to improve it, but eventually I want it to do that all automatically. Do it right the first time. And so what I learn is that there is an additional step, and that is I first ask it to um, generate tests with the most uh, precise or specific assertions, and then I add another phase, and that is where I ask it to go over the test that it already has generated and make it check that the assertions are as precise as possible. So here, after generating the test, review each assertion and explain why it's meaningful. Replace any weak assertions with precise behavioral validation. That is the step that I need to add to my process. So here I have incorporated the recommendations given by the agent in my instructions. So instead of saying generate tests, I say generate tests with precise assertions that validate the exact expected behavior based on the test data. And then I had add this extra phase where I ask it to review its own um, generated results and look for improvements. Then I prompt it here to redo the generation of the tests and it's doing that. And here it runs into a little problem that shows that it is handling these problems very well, because in its test data there was a John, but there was also a Johnson. And so it got confused by that, but it fixes that. And so in the end, it generates the test, and now it has 10 state transitions test for this one page that I showed you before. And it says in detail again what it did. So let's now look at the test that it generated to compare it with what we did before or saw before. So again, it has the name filter and the owner filter, but here it says before it even does any filtering, yes, there are three. Then it does apply the university filter, and then it clearly checks that it is two rows now in the table, and then it is John, and in this case, that is enough to make it a 1. So the test is now more precise in first time around, so no interference by me anymore. The instructions are clear, and the result is really good. I cannot see how I can improve this. I just showed you the result, and it's awesome. What do we now? Realize the consequences. For that, I would like to first give you my observations of the state of the art of testing. What I have seen myself in my own career is that the quality of tests is not guaranteed, and it's often not even assessed. And the completeness of the set of tests is often not even a goal. Typically, people just stop working on tests when the time is up, which is kind of weird because the people who work on it have quality in mind, but for some reason they don't look at the quality of their own work. It's understandable because typically people are on a tight time schedule. Machines are fast and don't get tired, so what do we see in the case of machines? Well, we have just seen that AI can generate high quality tests that are easy to read given the right prompt. AI also works systematically. I can show you here the list of tests that it has generated, maybe in too small font, but 10 state transition tests, all of this quality for this one page is pretty darn good. And AI also works fast. And therefore, I say AI can enhance software quality. This is very much needed. What we need to do is to find the prompts that make it do so, and I hope that this video helped you find the better prompts. The last part is about why tests are important if you are not convinced. So why do we need tests? Well, obviously to improve quality of the application. Even the best software developers find bugs in their software after they already thought it was complete. So that's one. Then if you don't have automated tests, then you have to test it by hand. Otherwise, your customers will find the bugs. And testing by hand is really time consuming, also incredibly boring. So we want to automate it. It also speeds up development because we can quickly set up a scenario while we are developing, and typically that has to happen several times in a row. The test enhances requirement specification because they're often much more precise, so they pin down the details of the specification. In the case of spec-driven development using AI, they also ensure that the AI that we give free access to our code doesn't make changes that affect previously established features. So we can rest assured that the previous features still work given a complete set of tests. We also can guard against regression when we do testing. Um, Sometimes a new feature can use the same code as previous features, and if people make small changes in that, they can break the previous features. Testing avoids that goes unnoticed. And last but not least, if you write tests, you also have to write your application code in a way that is better because you improve decoupling by writing testable code.